Hello students, in the previous chapter, that is chapter 5, we dealt with the topic of indefinite integration. That is, we know that suppose fx is a function and suppose we can integrate it by using suitable formulae. And if we get gx as the answer, we write it as gx plus c, isn't it? And we have seen the reason why we write a constant of integration during indefinite integration. Now here we are going to we are going to start chapter 6, that is definite integration. Now what is definite integration? Suppose in this particular case, that is in the integral of fx gx, suppose we integrate under a particular domain. Fx is put under a particular domain, say from a to b. We assign this domain to fx. That means we write this fact this way: the integral from a to b fx dx. Okay, where a and b are called as limits of integration. Now a is called as the lower limit and b is known as the upper limit. Then the answer that we get is this way, that is gx plus c, but between the interval a to b, that is between the limits a to b. So this is written this way now, right, by writing a square bracket and writing a and b over here. Okay, then after this what we do is that here gx, that is a, first the upper limit is substituted over here for x. So we write gb plus c always minus ga, the lower limit, plus c. And then we get gb plus c minus ga, and plus and minus minus c. So as a result, the c term goes away, the constant term goes away, and thus we get gb minus ga as our answer. And this answer is a definite answer, so it has a unique value. So in this way we carry out definite integration. So we are going to use all the formulae which we learned during indefinite integration and then carry out definite integration. Okay, so now what is the difference between indefinite and definite integration? We can say that in definite integration, first of all, we integrate within limits. So certain limits of integration are set. So the limits are fixed. Secondly, we get a unique answer. Okay, during indefinite integration, the answer which was coming were those answers for all functions actually. Okay, so we do not get functions over here, we get a unique answer for definite integration. And thirdly, there is no constant of integration applied. So there is no constant of integration. So this is the basic difference between indefinite and definite integration. Now you will understand it in a clearer manner when we start with the sums. So we begin with exercise 6.1. The first sum here, that is the integral of 4 to 9 1 upon root x dx. Okay, now this is a very simple sum. If you see, a very basic sum, we can write 1 upon root x as this way, that is x raised to minus half dx, and then use the formula for x raised to n. The formula for x raised to n is given as, that is the integral of x raised to n dx is actually x raised to n plus 1 upon n plus 1 plus c. Now since we are doing definite integration, there is no constant going to be written over here. So our answer comes out to be x raised to minus half plus 1 upon minus half plus 1 from 4 to 9. Okay, plus c is not written over here. Then in this case, we go further. We have to simplify now. This is the answer, but then this answer has to be written in a proper manner. We should get a definite value as the answer here. So half minus half plus 1, that is 1 minus half gives us half. So we get x raised to half upon half from 4 to 9. Now upon half we can write it as 2 over here. It comes to the numerator and becomes a reciprocal, as you know. X raised to half can be written as root x. So we get root x from 4 to 9. Now see the next step properly. We apply first, we put x as the upper value, upper limit of integration initially. So we get root 9 minus, always a minus sign. We put the lower value here now. So this becomes 2 into 3 minus 2, which is 1. And so the answer for our integration becomes 2. So thus we solve this integral in a very easy manner. Okay. Now just for practicing, you are going to write all these sums in notebook, needless to say. But for additional practice, you can try out this sum as homework. Say suppose I give you this way. Okay, get the answer and you can just compare the answer by asking me. You can WhatsApp the answer to me. I can tell you whether it is right or wrong. So do this sum as assignment just for additional practice, those who want to get thorough in this particular concept that is it. In the next sum, the question is the integral of minus 2 to 3 1 upon x plus 5 dx. Now in this case, see the integral, we remember that the integral of 1 upon x is log x. Okay, this part we remember, and therefore 1 upon x plus 5 also, the answer comes as log x plus 5. So in the next step itself we get the answer, of course. It becomes log mod of x plus 5. Okay, but we don't write c, remember, we write from minus 2 to 3. We put a square bracket, that square bracket is compulsory, from minus 2 to 3. Now what we do is we put x as the upper limit, that is 3 plus 5 minus log of the lower limit, that is minus 2 plus 5. Okay, now we don't have to write the limits over here. Limits already we have applied. Okay, so then it becomes log of 8 minus log of 3. Now you know that when two logs are subtracted, we can combine them and write them this way. That is log 8 minus log 3 can be written as log 8 upon 3. So this becomes the answer. You don't have to write plus c in the answer, again I am telling you. Okay. Now in the next sum, the third question that is there. The question is the integral of x upon x square minus 1. Now this particular sum you can do in two ways actually. You can either convert x square minus 1 and write it as x plus 1 into x minus 1. And then you can integrate by the method of partial fractions. However, there is one more method to be done by which you can get the answer in an easier manner, or quickly you can get the answer. And that method is this way, that is C. Suppose we take the denominator and we differentiate the denominator. Suppose d dx of x square minus 1 is done. And we get the answer for x square minus 1 as 2x, isn't it? The derivative of x square minus 1 is 2x. Now we observe the numerator. In the numerator, x is there, 2x is not there. So in order to get 2x, we put 2 over here. Okay, we multiply the numerator with 2 and thus we also write 1 upon 2. So this way we do. We bring 2, introduce 2 in the denominator, in the numerator this way. That is 2x dx. And we also, to balance it, we also put minus 2 over here. Okay, upon having done that, we now remember this fact. That now see, when you take out the derivative of x square minus 1, what do you get? You get 2x, isn't it? So this function is of the form this way, that is f dash x upon fx. Okay, this function is of this form, that is f dash x upon fx dx. And the answer is going to be log fx plus c. I have told you about this in the previous chapter. Okay, you can go and see how it has been done. Okay, so if the integral is of this form, then there is no need to do anything else. There is no need to use partial fractions or substitution or anything. Okay, you can directly write log fx as the answer. So here, actually we had studied that the integral of f dash x upon fx dx is log fx plus c. So over here, the case is that way, no? The derivative of x square minus 1 is 2x. So the answer comes out to be log denominator, that is log fx. Fx in this case is x square minus 1. Okay, plus c is not written. Rather we write it between. Oh, I didn't. Now in the third question, the question is the integral of x upon x square minus 1 dx from 2 to 3. The limits are 2 to 3 of integration. Now you can do this sum in two ways. You can either convert x square minus 1 as x plus 1 into x minus 1 and do by the method of partial fractions, which we studied in chapter 5. That was the last concept we studied actually. However, there is an easier method to be done, and that method can be done this way. That is, you observe the integral, you observe the function, you take the denominator, and suppose you find the derivative of the denominator. So d dx of x square minus 1. This has to be done in rough actually. So d dx of x square minus 1 comes out as 2x. Now observe the numerator. In the numerator it is x actually. So to get 2x, we have to multiply and divide by 2 in the numerator. Okay. So suppose we do that. So therefore our integral becomes I is equal to the integral of 2 to 3 2x. Okay, when we put 2x over here, we also have to multiply by 1 upon 2. So half the integral of 2 to 3 2x upon x square minus 1 dx. Now we use the formula, the integral of f dash x upon fx dx. Okay, and the answer for that integral is log fx plus c. Okay, this is a formula which we had learnt in the chapter 5, that is there. Okay, now observe our integral given here. The integral of f dash x. See over here, the integral of fx, that is the denominator, that is x square minus 1 is given as the derivative of the denominator. The derivative of the denominator x square minus 1 is actually 2x. So this integral is of the form the integral of f dash x upon fx dx. So the answer has to be log fx. So here our answer is going to be log mod of x square minus 1. Okay, but then plus c we do not write because we remember that it is definite integration. So from 2 to 3 it is written as, and half is there outside the log sign that is there. Okay, so now we substitute the values for x. Okay, over here, so it comes out as log. The upper limit of integration is applied first. So 3 square minus 1 plus, minus log of 2 square minus 1. In this way, okay, which comes out as half log of 3 square minus 1, that is 9 minus 1, 8, minus log of 2 square minus 1, 4 minus 1 comes out as 3. So which comes out as half log of, by combining the logs we write half log of 8 upon 3. So this comes out to be our answer over here. Going on to the fourth sum. The fourth sum, the integration of between 0 to 1. So integral from 0 to 1 x square plus 3x plus 2 upon root x dx is given. So over here what we do is we first separate out the terms. We write it this way, that is x square upon root x plus 3x upon root x plus 2 upon root x dx. Okay, and then we are going to get the integral from 0 to 1. X square upon root x is actually x raised to 2 minus half. Remember your polynomials actually. When you take the power, take the term to the numerator, the power gets subtracted actually. So this way. So 2 minus half plus 3x raised to 1 minus half plus 2 raised to minus half. 2x raised to minus half dx. Okay, then going further, let me put a bracket here so that it is clearer. Okay, then going further, x raised to 2 minus half comes out as, by cross multiplying etc., it comes out as x raised to 3 by 2 plus 3x raised to 1 minus half is actually half plus 2x raised to minus half as it is, it remains. And then in the next step, we find out the answer for each value, integral for each value. So we get x raised to 3 by 2 plus 1 upon again 3 by 2 plus 1, because each place we are going to use the formula x raised to n. Okay, here also 3 into x raised to half plus 1 upon half plus 1, and the same thing for the last term also. From 0 to 1. So that we get the answer this way. Now we modify the answer this way. Now x raised to 3 upon 2 plus 1, by cross multiplying we get x raised to 5 by 2 upon 5 by 2 plus 3 x raised to 3 by 2 in this case upon again 3 by 2, and the last case 2x raised to half upon half. Let us simplify one more step before applying the upper limit and the lower limit of integration. So thus we have now 5 upon 2 from the denominator, it comes up to the numerator, so it becomes 2 upon 5 x raised to 5 by 2 plus 3 into 2 upon 3 x raised to 3 by 2 plus 2 into 1 upon 2 becomes 2. Okay, it comes to the numerator and becomes 2 x raised to half. Now we can apply the limits of integration. So observe how it is done now. So we write 2 upon 5, 1 raised to 5 by 2, because the upper limit is 1. So first we'll write all the values with the upper limit and then go on to the lower limit, that is it. Now 3 gets cancelled here. So we get 2 it is 1 actually. So 1 raised to 3 by 2 plus 4 into 1 raised to 1 by 2. Okay, now we don't have to write from 0 to 1 because we already applied the limits for integration, minus everything with 0. Now x is substituted as 0 over here. You know that 0 into anything is 0. So we can just write it as 0 plus 0 plus 0. Just for the sake of writing, because we already know, but then for the sake of writing it. 1 raised to anything, any positive power is 1 itself. So 1 raised to 1 upon 5 is 1. So we get 2 upon 5 plus 1 raised to 3 by 2 is again 1. So 2, similarly plus 4. Okay. So then over here upon we get this way, that is 2 upon 5 plus 6, cross multiply and equalize the denominator. So we get 2 plus 30 upon 5, and so our answer comes out to be 32 upon 5. Consider this sum as an important sum. It can be asked for at least 4 marks in the exam. Now we go to the fifth question. In the fifth question, the question is the integral from 2 to 3 x upon x plus 2 into x plus 3 dx. This is purely partial fractions. We have to use the method of partial fractions over here. That is the simplest way, isn't it? So we start by using partial fractions. We write over here, let, if you remember, x upon x plus 2 into x plus 3 is equal to a upon x plus 2 plus b upon x plus 3. Upon taking the denominator from the LHS and taking it to the RHS, we get x is equal to a into x plus 2 x plus 3 upon x plus 2 plus b into x plus 2 x plus 3 upon x plus 3. Then whatever common terms are there, we cancel out, and thus we get this. Upon getting this, now we substitute, isn't it? We write let x plus 3 is equal to 0. Any one term as 0, say x plus 3 as 0. So therefore x is equal to minus 3. and therefore minus 3 is equal to a into this term plus b into minus 3 plus 2. So a goes away because minus 3 plus 3 is 0 in this case. So thus we get minus 3 is equal to minus b, and therefore b becomes 1 upon 3. Similarly, the other bracket, so let x plus 2 is equal to 0, therefore x is equal to minus 2, and therefore we get minus 2 is equal to a into this way. Okay, in this case b gets cancelled because minus 2 plus 2 is 0, and therefore we get the value for a, and a comes out as 1 upon minus 1 upon 2. Okay, so we get the value for a and b in this way. In the fifth question, the question is the integral from 2 to 3 x upon x plus 2 into x plus 3 dx. Now by looking at the sum, we know that it has to be done by the method of partial fractions. So we write over here, let x upon x plus 2 into x plus 3 is equal to a upon x plus 2 plus b upon x plus 3. This will remind you of partial fractions which we did in the previous chapter, that is there. Okay, then therefore upon cross multiplying with the denominator from the LHS, we take the denominator to the RHS actually, we get x is equal to a into this term x plus 2 into x plus 3 upon x plus 2 plus b into the same thing we cancel out what the common terms are from the numerator and the denominator in each case. So we get x is equal to a into x plus 3 plus b into x plus 2. Then after having obtained it, we write let any one of the brackets, let x plus 3 is equal to 0, and therefore x is equal to minus 3, and therefore minus 3 is equal to a into minus 3 plus 3 plus b into minus 3 plus 2. Therefore we get a term goes away, so we get minus 3 is equal to minus 1b. Therefore b is equal to 3. Similarly, the other bracket, say we write let x plus 2 is equal to 0. The other bracket, x plus 2 is equal to 0, and therefore x is equal to minus 2, and therefore we have minus 2 is equal to a into minus 2 plus 3 plus b into minus 2 plus 2. B term gets cancelled, so we get minus 2 as a, that is a value comes out as minus 2. So thus we get the both the values for a and b. So our integral now becomes the integral of, the question becomes the integral of from 2 to 3 a upon, see a was actually, a is minus 2, so minus 2 upon, in this case it is minus 2 upon x plus 2 plus b upon, b is, we got b as 3, so 3 upon x plus 2, x plus 3 in this case dx. Okay, so in this way we get these integrals. Now of course we solve it, we can solve it directly also, there is no need to separate these values, we can even solve it directly. So we get the answer in each case as, we get the answer in each case as this way, that is minus 2 log of mod of x plus 2, because 1 upon x gives us log x, the integral of 1 upon x gives us log x, again I am telling you, so this term is going to become log x plus 2 plus 3 log of mod of x plus 3 from 2 to 3 actually. I should have put a mod sign there, from 2 to 3. Okay, then in the next step what we do is that we first put the upper limit of integration over here. So thus we are going to get minus 2 log of mod of 3 plus 2 plus 3 log mod of 3 plus 3. Okay, and also minus the same thing but with excess 2 over here. So minus 2 log mod of 2 plus 2 plus 3 log mod of 2 plus 3 this way, and thus we get minus 2 log 5 plus 3 log 6 minus and minus becomes plus, so plus 2 log 4. Okay, again minus and plus becomes minus, so minus 3 log 5. Okay, we can put a mod sign everywhere. Now these two are similar terms. See, minus 2 log 5 and minus 3 log 5. These two are similar terms. So we can add them together. So minus 3 minus 2 gives us minus 5. So we are going to get minus 5 log 5. So here we get 3 log 6 plus 2 log 4 minus 5 log 5. Now whenever you write logarithms, we have seen this earlier that the number which is written to the side can be added, can be written as the power, is actually the power of the log. See, for example, if you have m log x, it can be written as log x raised to m. So that is what we are going to do over here. Okay, so 3 log x is written as log 6 cube plus 2 log 4 is log 4 square minus 5 log 5 is log 5 raised to 5. Okay, which is actually log 6 cube is log 216 plus log 4 square is log 16 minus 5 log 5 raised to 5, which is log of 5 raised to 5. 5 multiplied 5 times gives us 3125 this way. So now again one more concept of logarithms to remember. When two logs are added, we can combine them by multiplying the numbers together, and similarly upon subtraction we can combine them by dividing the numbers. Okay, so over here it becomes, we can combine all these logs by writing log 216, it is 216 plus log 16, so 216 into 16 upon 3125 this way. Okay, and therefore it becomes log, upon multiplying we get log 3456 upon 3125. I realize one thing, because we are writing numbers, we may not have to write the mod sign everywhere. Okay, and therefore we get this answer that is it. So here we are concluding by writing, by including only 5 sums. I'm including only 5 sums from this exercise as of now. We can continue the remaining sums later on in the next lecture. Okay, practice these sums, make them thorough, write them in the notebook, so that the concept becomes, initial concept at least becomes proper in the mind. So thank you. We meet in the next lecture now. Do subscribe and like the channel. Bye students.